Okay, so let's go over these here. Our first reaction, we have an ionic compound in calcium oxide reacting with an element in sulfur. That's what kind of a reaction? Single replacement. Okay, so who's got to switch with who? Sulfur and oxygen have to switch. So calcium's new partner is sulfur, okay, and oxygen is going to end up by itself. Now we've always said that there are things we need to check, okay, when we have a single replacement reaction. The first thing is we need to check any ionic compounds and properly drop and swap them. Okay, calcium is a +2, sulfur is a -2, so that compound is okay the way it's written because it already adds up to 0. Okay, we got to check for special elements. Is this one of them? Yes, it is. All right. Give them a mark for CAS and 1 mark for O2. Now we've got to balance the reaction. So we should start with sulfur because it obviously has the biggest number. There's 8 of them over here, so I need to put 8 over there, which gives me 8 calcium. So I have to go back over here and give myself 8 calcium. And then I've got 8 oxygen, so 4 times 2 is 8 calcium. So that's what your balancing should look like. 8, 1, 8, 4 for 1 mark. Okay, so each of these will be out of 3. All right, for number 2, we have a combustion reaction. Carbon-hydrogen containing compound reacting with oxygen gas. So the products are always what? Carbon dioxide and water. Now, are we going to have big numbers here? Yeah, okay. The bigger the carbon compound, the bigger the numbers for balancing are going to have to be. Okay, and that's all right. We have 2 rules for balancing. Do we have to apply them both? Yeah, because 10's an even number, so we got to start with a 2 here. Okay, so 2 times 10 is 20, so I need a 20 over here. Okay, 2 times 22 is 44. 22 times 2 is 44. So now my my hydrogens all work out. Now I've got to look at my oxygens. Okay, so 20 times 2 is 40. Okay, plus 22 more is 62. 31 times 2 is 62. So give them 1 mark for CO2, 1 mark for water, and 1 mark for the balancing numbers 2, 31, 20, 22. Questions on number 2? All right. For number 3, okay, I have iron 3 hydroxide. How do I know it's iron 3? Right, okay. Hydroxide's a -1 and there's 3 of them. That means this iron has got to be a +3. That's going to be important on the other side when I have to drop and swap the ionic compound it will be in. Okay, so this is a double replacement reaction. In a double replacement reaction, we swap the metals. All right, so that means iron's new partner is phosphate. Okay, and sodium's new partner is hydroxide. So I need to drop and swap those. Looks like they're good to me. Okay, because this, we said, is a +3, phosphate's a -3. This is a +1, that's a -1. Okay, so those ones are okay, dropped and swapped. So give them a mark for iron 3 phosphate, which is FePO4, okay, and 1 for sodium hydroxide, NaOH. Now we've got a balance. What should we start with? We can start with hydroxide, we can start with sodium. It makes no difference. We're only going to be adding 1 number here, okay? Because they go together on the other side, and they have the same number on the reactants. They're both a 3, okay? So if I go over here and balance my hydroxides with a 3, that balances my sodiums, and everything else is a 1. All right, so give them a mark for 1, 1, 1, 3. Any questions on number 3? All right, for number 4, I have phosphorus, an element, reacting with nickel, another element. That's what kind of a reaction? It's a synthesis reaction. Okay, it's going to make what kind of a compound? Ionic. Have I told you about this trick and played it on you once already? Okay, fool me once, shame on you. Fool me twice, shame on me. Okay, hopefully I didn't get anybody twice on that one. Okay, because I don't have that many tricks and I just keep playing them. Yeah. Okay, so we got to write this one as Ni, then P. Metal first, non-metal second. Okay, what do I have to do with this compound now? I have to drop and swap, but I have an issue. Nickel has more than one possible charge, and since it's an element, I don't know which one it is. So which one do I pick? I pick the most common one, which is 2. All right, so this is a +2. Phosphorus is a -3, so we're looking at Ni3P2, okay, for our swapped and dropped compound. That's 2 marks. Okay? There's no part marks on this one. They either got this right and they get 2, or they didn't get it right. Okay? All right, P4 is what I got to balance first. So there's 4 over here, and now there's 4 over there, but that gives me how many nickel? 6. So you need 30 cents on that side. Not many of you got that. Okay. So there's 6 nickel on this side. Everyone got that? Yes? It's a terrible joke, kind of. Okay. Number 5. I only have one compound as a reactant. So what kind of reaction is that? Decomposition. So it's got to split into its 2 elements. Okay. What do I have to look for? Special. Are they? As 2s. All right. Give them a 1 mark for N2. Give them 1 mark for H2. Now, should probably balance the nitrogen first. Okay? Just because if I go and try and balance the hydrogens, well, I could balance either one. It doesn't really matter. Okay? If I put a 2 in front of this, okay, does that balance my nitrogen? Okay, what do I got to do to my hydrogen on the other side? Put a 3 in front of it, right? Give them 1 mark for that. Okay, so the quiz is out of 15. Please give them a mark out of 15. Write it at the top. Let them see it, then put it in the box, please. Once you've done all that, take your phone out and open up your lab report that you handed in yesterday. I want to go over the lab report. Okay, so yesterday we went over the mole equation. We're going to review the mole equation here again real quick. Going to go over 4 more examples of how to solve mole equation problems. Then we're going to work some more on the mole equation. Okay? Now, in the mole equation, N stands for the number of moles. Okay? Little m stands for mass in grams, and big M stands for molar mass in grams per mole. All right? And you can always calculate big M using what? Your periodic table. Okay? So you'll never have to solve for big M using the equation. You'll just have to figure it out from the periodic table. Okay. So question number 1. How many moles of calcium carbonate are in 125 grams? Okay. First step is always to write down our givens. Okay? It asked how many moles. That's N. That's the question mark. We don't know what that is. Okay? Then it tells us the material, calcium carbonate. All right, so I got to figure out the molar mass of that stuff. Calcium is 40.08, and there's how many calciums here? 1. Okay, how many carbon are here? 1. Okay. How many oxygen are here? 3. Oh, not plus, times 3. Okay, 16 times 3. All right, so when we add all those together, okay, we got 52.09 plus 48 is 100.09, right? Someone double check my math. I should not add in my head. It's a really bad idea. Someone else check my math. Okay, so now that I've got, whoa, I forgot units. Cardinal sin. Okay, forgot units. Grams per mole. Now, I have little m. Okay, that was the other thing given to me in the question. 125 grams. Am I right on that? Okay. Okay, so I have the mass in grams already. Okay, I have the molar mass there already. Now I need to calculate n. So N equals little m over big M. Do I need to move anything around? No. Okay, not in this one. It's already set up for N, and that's what I'm looking for. So I just plug in my numbers. Okay, 125 grams divided by 100.09 grams per mole. Okay, and you don't have to write the units in when you plug in the numbers. I just do out of habit. Okay. Okay, so we got 125 divided by 100.09. And it didn't get the divide. All right, so we're looking at 1.25 what? What are my units here? Moles. Right? N is the number of moles. I hope my units are moles. Plus, oh, that's the 16. 16 times 3. Sorry. Yeah. This is why I type most things. Okay. My grade 6 teacher would keep me in every day to work on my penmanship. And you know what I told her? I could see the future. I'm not ever going to need to write stuff. Computers will be everywhere. This was before computers were everywhere because I'm that old. Okay? I was right. I like to be right. At some point I'll look her up and tell her I was right. Okay. That one making sense? Okay, so that's probably like a 3-mark, maybe 4-mark question, depending on how generous I am. Okay, probably 3. All right, 1 mark for the givens. Okay, 1 mark for the mathematical operation involved. Okay, and 1 mark for our final answer. When you're problem solving, guys, especially on an exam, do me a big favor. Circle or put something around your answer so I can find it. It's much easier for me to mark starting from the end and working backwards. Okay? Right? When I'm marking a test, it's way easier for me to start at the end, your final answer, and work backwards. If your final answer is right, I can just kind of, quickly cursorily look over your work and know that you probably did it right, because most of the time you don't just randomly guess the right answer for something like this. Okay? Plus, I also know how you can generally do it wrong, and if I see that, I kind of know from there where I should look to try and give you part marks. Okay? So if you can, circle your answer. Okay. Number 2. What's the mass of 2.7 moles of lithium phosphide? All right. What is the mass? So M is the unknown. Little m is the unknown. Okay? Of 2.7 moles. That's N. And then I can calculate big M because they told me it's lithium phosphide. Are you going to get the formulas on the exam in the question like that? Nope. I'm going to give it to you in words. I'll tell you that right now. Okay? You're going to have to do the formulas right. Okay? I would write that as, in words, lithium phosphide. Okay. So we've got to calculate the molar mass of this stuff. So lithium is 6.94, and there are 3 of them. Okay? And then we've got phosphorus, which is 30.97. Is that right? Okay? All right. All right, so 51.79 is our molar mass. Grams per mole. Okay. 1 mark. Number of moles equals mass over molar mass. And I'm trying to solve for little m. Do I need to move anything? Okay. How do I move big M? Multiply, right? Multiply both sides by. Because remember, there's only 2 rules in algebra. If you want to move something, do the opposite. Right now I'm dividing by M. That's why I multiply to get rid of it. And what I do to one side, I do to the other. Okay. So I've essentially then done this. Multiplied both sides by M, and it's canceled over there. Come over to the other side. Okay. You get a mark for that. Okay, then we got to plug in our numbers. So big M was 51.79, and N was 2.7 moles. Probably get a mark for that. All right, we're looking at 139.833. So 139.83. What? Grams, right. Okay, that would be your fourth and final mark for that one. Hey, is this ringing a bell from yesterday? Okay, so those are the two easier ones. Okay, the other two have that extra step involving what number? The guy's number, right. The guy's name is Avogadro. Okay, Avogadro's number, 6.02 times 10 to the 23. What is that number besides the guy's number? Oh, no, what does it tell us? It's the number of, right, it's the number in a mole. Okay, number of molecules in a mole, number of atoms in a mole, depending on what you're dealing with. Okay, all right. So for number 3, it's asking us how many molecules of iron 3 oxide are in 230 grams. Okay, so number of molecules is what we're looking for. It's the question mark. Okay, we can get big M because it's Fe2O3. Okay, so that's going to be 55.85, right? I always guess it wrong. It's 58.55, isn't it? No, I was right. 55.85. Okay, times 2 plus 16 times 3. Okay, that's oxygen, that's the iron. Okay, so 159.7 grams per mole. Okay, and the other thing they tell us is the mass, 230 grams. All right, so there's our givens. That's 1 mark. What do I need to calculate next? I can't do that yet. I got to calculate one thing before the number of molecules. I got to calculate the number of moles, right? Okay, I got to calculate N. That's all I can calculate right now. I can't use Avogadro's number without the number of moles. Okay, so if I was lost and I didn't know where to go, okay, at this point, I have 2 parts of the mole equation. Agreed? Okay, so what I would say is if I've got 2 parts of the mole equation, calculate what I can. All right? It's probably the next step. In this case, it is. All right, so N equals little m over big M, and I have those 2 numbers, 230 over 159.7. Okay, so we're looking at 1.44 moles. Okay. So there'd be another mark. Taylor, question? Yeah. All right. Now that I know the number of moles, and I remember, of course, that Avogadro's number tells me the number of molecules in a mole, can I calculate the number of molecules? Yeah, what do I do with those 2 numbers? I multiply them. I know the number of moles and the number of molecules in a mole. Okay, I got to multiply in order to get, okay, how many molecules there are. Okay, so n times 6.02 times 10 to the 23, so that means 1.44 times 6.02 times 10 to the 23. Okay, so we would get another mark for that step. Okay, and then when we punch this into our calculator, what do we need to make sure we do with Avogadro's number? It's got to be in brackets. All right, so I'm going to take my answer there and multiply it by Avogadro's number, 6.02. Okay, get the little e. Okay, 23. Okay, so it says I have 8.67 times 10 to the 23 molecules of iron 3 oxide. Okay, so that'd be a 4-mark question. Okay, so something to remember, Avogadro's number always goes with n. Okay, you're either going to be multiplying n by it, okay, or you're going to be dividing a number of molecules by Avogadro's number to get n. Okay, but Avogadro's number is always tied to the number of moles. Okay, it's always tied to the number of moles. All right. Questions on that one? Anyone still need it? All right, 4th one. We want to find the mass of a certain number of molecules. Now we said number of molecules is always tied to, Avogadro's number is always tied to the number of moles. In this case, I have to use Avogadro's number and this number that they give me to find the number of moles. Okay? So Avogadro's number tells me how many molecules are in a mole. And I know how many molecules I have. So how do I get the number of moles? Divide, right? Okay? I know number of molecules. I want to divide by molecules per mole because that will leave me with moles. Okay? The molecules will cancel. If I divide molecules, okay? If you're thinking about it here, okay? Molecules, okay, divided by molecules per mole, okay? The molecules cancel and you're left with moles, okay? Avogadro's number is the number of molecules in a mole. All right. So, things we're given. We're given number of molecules. Okay, 5.42 times 10 to the 21. So do we have more or less than 1 mole? Less. Yeah. Oh, man, really struggling here. Okay, 5.42 times 10 to the 21. Okay, and we are told what it is. Okay, it's nickel 2 nitrates. Okay, so we might as well calculate the molar mass of that right off the bat as well. Okay, so nickel's atomic mass is 58.69. How many are there? Just one, right? Are there any numbers next to nickel? Okay, there's no brackets tied to nickel, right? So there's only one. How many nitrogen are there? 2. Okay, so there's our 2 nitrogens. And there's how many oxygen? 6. All right, so we'll have our 58.69 plus 14.01 plus, times 2, plus 16 times 6. All right, so we're looking at 182.71 grams per mole. Okay, if I want to calculate little m, I need n and big M, and I don't have n. So we're going to calculate n right now. N's going to be the number of molecules, 5.42 times 10 to the 21, over 6.02 times 10 to the 23, Avogadro's number. Right? Am I going to get a decimal here? Yeah, because I definitely have less than a mole. Okay, looks like considerably less than a mole. All right, so we have to put both of them in brackets. 5.42 okay, divided by 6.0223. All right, so we're looking at 0.009 moles. All right. Okay, now that I have n and big M, can I calculate little m? Yeah, I can. All right, so we got a mark for givens, we got a mark for calculating n. Okay, then we have to take n equals little m over big M, and we've got to manipulate for little m. So we've got to multiply both sides by big M. So you get another mark for that. Okay? So then we'll take our 0.009 n, multiply it by our molar mass, big M, so 182.71. Okay? You get a mark for that. Alright, so we're going to have 1.64 grams. Right, 1.64 grams of this. Fifth mark. Okay, so that one's the most involved. Okay, has the most steps to do. Questions on those? Okay, take out those worksheets from yesterday on the mole equation. Okay, let's get going on those. I don't think too many people got past question number 2 yesterday in the box. There's 2 of them. Okay. So remember, guys, when you start a question, the first thing you do is write down your givens. That will help you figure out which way you need to move the formula around to get what you want. Okay?